Hello, welcome everyone to lecture number 24 of Fundamentals of Computing. This lecture is on unguided transmission media. Here I will cover types of unguided, that is wireless transmission media, and the comparison of a guided and unguided transmission media, where I will discuss in what situation which type of transmission media is preferred and why. Before going into the detail of a unguided transmission media, there are a few terms that one should know. These are bandwidth, which is nothing but it's a maximum amount of data that can be transmitted over a network in a given amount of time. It's also known as data transfer rate. Noise, that is unwanted interference, or you can say unwanted signals that disrupts the transmission of the data signals. This interference can come from either internal or external sources to the network, and why this is called unwanted, because it can lead to data loss, errors, or reduced data transfer speeds. Another term is attenuation. This is nothing but it's a loss of signal strength in networking cables or connection. It is measured in decibel, that we call as a dB or voltage. It may cause signals to become distorted or affect the reliability and quality of the signal. And another term that one should know is a signal quality. It is the most important term. It refers to the clarity and strength of the signals transmitting data between devices. So, I will frequently use these terms in my next slides. So, let us just start with the unguided or wireless transmission media. This may be microwaves, satellites, radio waves, or infrared. So, what are these unguided or wireless transmission media? It is nothing but here the data is sent from one device to another in a network without the need of physical wires or cables. It represents bits of data, and typically unguided media represents bits of data using the radio waves, microwaves, or infrared waves. So, let us just start discussing about each of them one by one. This diagram shows the different types of wireless transmission media, or you can say unguided transmission media. It may be radio waves, infrared, satellite, or terrestrial microwaves. So, let us start with the radio waves. Radio waves is nothing but it is an electronic waves that are widely used for wireless communication, including broadcasting, that is AM and FM radio, television signals, cellular networks, and Wi-Fi. So, from a diagram you see that there is an antenna and this is broadcasting the signals. This electromagnetic wave ranging in frequencies between 3 kilohertz and 1 gigahertz that are normally called the radio waves, and they can travel a long distances and penetrate some obstacles like walls. These are omnidirectional. Omnidirectional means what? It will transmit in one directional, so it propagates in this way, and it means what? There is no defined direction, means it is propagating in a this diagram shows that in all the directions. The radio waves are useful for multicasting, in which there is one sender but many receivers because of their Omnidirectional property means the signals has been transmitted in all the directions. FM radio, television, maritime radio, cordless phones and paging are the examples of multicasting. It is used in wide area network and mobile cellular phones. It provides a high transmission rate. So, this was all about the radio waves. Second one is the terrestrial microwaves. From the diagram you see that there is a dish antenna and this shows the focus point, and it won't penetrate the wall, whereas radio waves penetrates the wall. So, let us see the characteristics or the features of this terrestrial microwaves. It transmits the focus beam, whereas radio waves is omnidirectional. It is sort of broadcasting in all the directions, and it uses transmission antenna. Microwave antennas are usually placed on the top of the buildings, towers, hills and mountain peaks and resemble satellite dishes like this. These are the electromagnetic waves having the frequency in the range 1 gigahertz to 1000 gigahertz, and these are unidirectional, not omnidirectional. It means what? Sending and receiving antennas are to be aligned in the case of terrestrial microwave, which is not required in the case of radio waves, because radio waves is omnidirectional where it broadcasts it in all the directions. The frequency range of terrestrial microwave is from 4 to 6 gigahertz to 21 to 23 gigahertz. It supports a bandwidth from 1 to 10 Mbps. It is inexpensive for short distances but expensive for longer distances because it requires high torque for longer distance. Loss of signal is affected by environmental conditions and antenna size. A microwave transmission is susceptible to weather conditions. That means that if there is a change in the weather such as rain, wind, then it may or it can distort the signals. Microwave signals is cheaper than using cables. Yes, that I have already discussed, that it supports the bandwidth from 1 to 10 Mbps. So, this was about the terrestrial microwave. Next one is the satellite communication. Here you can see there is a satellite and one user is placed here, another user is here, this user is the sender, this is the receiver. So, it transmits it, that will receive by the satellite, and then that will send, which is received by the antenna which is placed on the earth station, and then that is communicated to the user 2, that is the receiver. So, in this way the data or the signal is transmitted from sender to receiver in the case of satellite communication. So, let us discuss its features. In this, signals are transferred between the sender and receiver using a satellite that is stationed in a space, typically 35,400 km above the equator. The signal, which is a beam of modulated microwaves, is sent towards the satellite and the satellite amplifies the received signal and transmit it back to the receiver antenna present on the earth. Its coverage area is more than terrestrial microwave. It is used in mobile and wireless communication application, and it is easy to install. Here the signals travels a long distance to and from satellites, which can affect the real-time communication like phone calls and video conferencing. It is used in weather forecasting, radio or TV signal broadcasting, mobile communications, etc. Its development requires more time and cost because launching and maintaining a satellite is very expensive. The satellite needs to be monitored and controlled at regular intervals so that it remains in the orbit. Generally, the life of a satellite is about 12 to 15 years. They allow for communication over very long distance. That is the advantage of this satellite communication over the terrestrial microwave and others, including international and intercontinental connections without the need for physical infrastructures on the ground. These are less affected by geographical obstacles like mountains or buildings, providing a long, consistent and reliable signal. Then another type of wireless transmission media is infrared communication. So this we are using in our home and we are very much familiar of it. So from the diagram you see that there is a wall. If a TV is placed on both the sides of a wall, they are not going to affect each other. So what are the properties of this infrared communication? These are widely used in TV or the VCR remote controls. It enables computing devices to communicate via short range wireless signals and used to transfer digital data. Infrared waves block interference with other system waves. For example, when a user is communicating using infrared waves in a room, such as controlling a TV with a remote, it does not affect the neighboring TV. These waves are not used for long distance communication and it can transmit a signal at a very high data rate because it has a high bandwidth such as 400 terahertz. And the Infrared Data Association has defined a data rate of 75 kbps, which covers a distance of up to 8 meters. It provides better security and minimum interference, and it's widely used in security systems including your motion detectors and infrared cameras. This infrared technology is used in many consumer devices like remote controls for television, air conditioners and other appliances. So this was all about the different types of unguided or wireless transmission media. Now we have discussed about the wireless as well as the wire transmission media. So under what situation which will be preferred? That depends upon their advantages and disadvantages. First we will talk about the guided transmission media, that is the cable, twisted pair, coaxial cable, fiber optic, etc. The advantage of this guided transmission media is what? It is reliable, secure, it has a high bandwidth, less susceptible to interference and has a predictable performance. So what is reliability? Reliability is nothing but you can say that whether it's optical fiber or twisted cable, that will provide the stability. So that is the reliability. There is a less chances of signal loss. So we can say that it is more reliable. Security on the other hand means what? Difficult for hackers to intercept the signals. It has a high bandwidth. It means what? It enables the transmission of greater amount of data at faster speed. less susceptible to interference. It means what? It ensures the integrity of signal, and predictable performance means what? Stability. For this, the stability is required. So these are the advantages of a guided transmission media. What are the disadvantages? That is the limited mobility. Limited mobility means what? Since the devices are connected to each other physically, that is through the cables, so its mobility will be less, and there is a restriction on it, and for the mobility and the flexibility. Vulnerability to physical damage. Yes, the risk of physical harm is more in this case because cable can break. The chances of the breaking of a cable will be high. Cost for long distance because installation cost is high. Infrastructure dependency, since the cables are used to connect the devices in a network. So if I am going to do some changes in the existing infrastructure, under that situation it has to be restructured. And last one is environmental impact, that is the disposal of guided transmission media. So this is all about the advantages and disadvantages of guided transmission media. Now let's talk about the unguided or wireless transmission media. Yes, this is flexible, or flexibility is there. Flexibility means what? Devices can connect from anywhere within the signal range, providing mobility and convenience. No need for physical connection, it is easy to install, and scalability is there. Scalability means what? New device can be added easily into the existing network without reconfiguration. It has some disadvantages also. So what are the disadvantages of unguided or wireless transmission media? First one is interference. It means what? Signals can be disrupted by other electronic devices and weather condition. Security means what? People can have unauthorized access. So in that way it is less secure. Range limitation, it has a limited range. And signal quality, obstacles like building and walls can decrease signal quality. And bandwidth, it has a lower bandwidth compared to guided transmission media. So when we want to have a higher bandwidth, that is high data rate, obviously for that we have to go to the transmission media. And when the flexibility is required, scalability is required, and range is not a matter, in that case we will prefer unguided or wireless transmission media. So this is all about the guided and unguided transmission media. Thank you.